Stop optimizing for model accuracy and start auditing your hardware budget. The release of Qwen3.8 introduces an efficiency cliff where standard inference setups fail, forcing engineers to choose between specialized ASICs or quantized GPU clusters just to keep costs viable in production. Most developers are asking if this new model is smarter, but the real question you must answer right now is whether your current infrastructure can run its thinking budget architecture without breaking the bank. When a new AI model drops, the leaderboard score rarely tells the whole story about what happens when it hits your server rack. The Qwen3 series transitions from purely dense architectures to a hybrid of dense and mixture of expert models that scale up to 235 billion parameters. This shift is designed for both edge devices and massive cloud clusters, but it fundamentally alters memory bandwidth requirements compared to previous generations. If you try to run this new architecture on hardware built for the old generation, you will hit a wall where performance degrades sharply as model size increases. The core change driving this hardware demand is what we call an adaptive thinking budget mechanism. Unlike standard single-pass inference, where a model generates an answer in one go, Qwen3 introduces a system that splits generation into two distinct phases. First, it generates internal reasoning wrapped in XML tags, producing up to 512 tokens of thought by default before appending that context for the final response. This dynamic allocation of compute based on task complexity is a departure from static model switching and creates a specific hardware bottleneck. This sequential token generation with strict budget constraints means your inference infrastructure must handle variable latency spikes rather than steady-state processing. While native 256K context windows, expandable to 1 million tokens, and support for 119 languages are major wins for capability, they demand sophisticated engineering to maintain acceptable speed in production environments. Teams relying on legacy GPU setups may face a hard decision: invest in specialized hardware or quantization pipelines to unlock these new thinking capabilities, or downgrade to smaller dense variants that sacrifice reasoning depth for immediate deployment viability. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The friction becomes apparent when you look at the specific implementation challenges reported by early adopters. Standard OpenAI-compatible API wrappers often fail to handle the continuity of thinking sessions correctly if token limits are not meticulously managed. This can lead to truncated reasoning processes where the model cuts off mid-thought, effectively disabling its most valuable feature. To avoid this, engineers must write custom inference logic or accept that their current configuration cannot support the full potential of the new architecture without significant modification. This reality forces a fundamental shift in how engineering leads select models for production systems. You can no longer choose based on benchmark scores alone, because the best model for accuracy might be the most expensive choice if it requires hardware. Your cluster cannot support efficiently due to mixture of expert sparsity or multi-step thinking latency. The cost drivers have moved from simple parameter counts to inference complexity, meaning a 235 billion parameter model running on standard GPU setups may suffer severe performance degradation compared to optimized clusters handling the same parameters with FP8 quantization. The efficiency cliff is real because the new architecture demands specific computational patterns that generic hardware struggles to exploit. Production deployments will increasingly rely on specialized ASICs or FP8 quantized GPU clusters to remain viable without incurring prohibitive latency costs. This means your total cost of ownership calculations must now factor in thinking budget overhead alongside raw compute power. If you plan for linear scaling but the model scales exponentially based on reasoning depth, your cloud bills can spiral out of control within days of deployment. Consider the decision framework you need to apply today before integrating these models into your stack. You must ask if you actually need the deep thinking capability or if a simpler dense variant suffices for your use case. Then, evaluate whether your current hardware can handle the sequential load without dropping tokens or triggering timeout errors. Finally, determine if investing in quantization pipelines is worth the engineering effort to unlock performance on existing GPUs versus upgrading to specialized accelerators that natively support these new architectural patterns. The choice is no longer just about model size. It is a strategic decision about infrastructure compatibility and long-term cost management. Teams ignoring this shift risk building systems that are technically impressive but financially unsustainable at scale. The Qwen3 series forces you to confront the reality that more parameters do not always mean better performance if your hardware cannot execute them efficiently. You must now provision systems capable of handling sequential token generation with strict budget constraints or accept significant performance degradation in production. This is where career relevance meets engineering judgment. As a practitioner, understanding these trade-offs allows you to guide leadership away from chasing SOTA benchmarks and toward building robust, cost-effective AI applications. The ability to explain why a smaller model might be the better business choice because it fits your existing hardware constraints is becoming as valuable as knowing how to train a larger one. It shifts the conversation from feature lists to system design trade-offs that define success in real-world deployments. The industry is moving toward an era where software and hardware are tightly coupled, meaning you cannot optimize one without considering the other. The release of Qwen3.8 serves as a stark reminder that architectural innovation often outpaces infrastructure readiness, creating gaps that only careful planning can bridge. By focusing on your specific deployment needs rather than generic capabilities, you ensure your AI systems remain reliable and affordable over time. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.